Hi class. So we have already done in a previous video an introduction to coordinate geometry where I explained you how to plot the point in a coordinate plane. What is a coordinate plane? Everything we have done. In this video, let us see if there are 2 points in a coordinate plane in any quadrant. For the sake of our convenience, I have taken the point in the first quadrant. Then how to calculate the distance between those 2 points. Now suppose you have A, x1, y1 and B, x2, y2, 2 points in a coordinate plane. Then of course, if you drop a perpendicular, suppose AM over here and AP suppose on the y-axis, then M is nothing but x1 comma 0 and this distance OM is x1. Similarly, P, the coordinate of P will be 0 comma y1, point on y-axis, and this distance is nothing but y1 unit. Similarly, if I drop a perpendicular, suppose BN on x-axis, so N will be what? x2 comma 0. And suppose I drop a perpendicular from B on y-axis, suppose BQ, then Q coordinate will be 0 comma y2, isn't it? Now ON will be x2 unit. Look over here, OQ, be careful, this is y2 unit. And this distance PQ will be y2 minus y1, very important, okay? And MN will be x2 minus x1 unit, the distance. Now what I'll do, I'll join AB. We need to calculate this distance only. And I'll draw a triangle. Suppose ABC, right angled at C. So clearly AC is parallel to MN and AC will be equal to MN. So AC will be x2 minus x1. Similarly, BC is parallel to PQ, isn't it? And BC is equal to PQ, which means this is y2 minus y1 unit. Now in triangle, when you talk about in triangle ABC, the hypotenuse square, AB square, is equal to perpendicular square plus the base square. Am I clear? AB square equals to BC square plus AC square. Now, so AB will be root of y2 minus y1 whole square plus x2 minus x1 whole square. And this is your distance formula. This is the formula to calculate distance between 2 points in a coordinate plane. Am I clear? And at times you will see that this is written as y1 minus y2 whole square plus x1 minus x2 whole square. Doesn't matter a lot because y2 minus y1 whole square and y1 minus y2 whole square gives you the same value because of the square. Okay, so this formula we are going to use to calculate the distance between 2 points. Now, by distance formula, how can you prove that a given quadrilateral is a parallelogram? A given quadrilateral, number one, how can you prove that it's a parallelogram? Just show that opposite sides are equal. Our work is done. Okay? And how can you prove that a given quadrilateral is a rhombus? Is a rhombus by distance formula. Show that all sides are equal in magnitude. Done. Then it's a rhombus. Number 3. How can you prove that a given figure or quadrilateral is a rectangle by using distance formula? For this you need to prove that opposite sides are equal plus diagonals are equal, or you can say opposite sides are equal plus one of the angle one of the angle is 90 degree, then our work is done. And last, how can you prove that a quadrilateral is a square? By distance formula, same. Prove that all sides are equal plus the diagonals are equal, or all sides are equal plus one of the angle is 90 degree. So by these logic we can tell whether a quadrilateral is a parallelogram, rhombus, rectangle or a square. Okay, now let us look at the sums from the exercise. Now look at sums from exercise 19.4 ML Aggarwal. Okay, A is a point on y-axis. Come on, A is a point on y-axis whose ordinate is 4. So A has to be 0, 4, because on y-axis any point is 0, y. Ordinate value is known to you and abscissa is always 0. And B is a point on x-axis. So B, whose abscissa is -3. So B has to be -3, 0. Very important. Find the length of AB. Very easy. See, your length of AB will be root of, I'll just write the formula, y2 minus y1 whole square plus x2 minus x1 whole square. Suppose this is my x1 y1, this is my x2 y2. Okay, so your AB will be root of, see, 0 minus 4 whole square plus this is -3 minus 0 whole square. So your AB will be root of, this is -4 whole square plus -3 whole square, which is equal to, if I'm not wrong, this is 16 plus 9, so that's root 25. That's 5 unit. Done. So the length of AB is 5 unit. Okay. Look at 4 part 1. Find points on the x-axis which are at a distance of 5 unit from the point 5 minus 4, which means distance is given to you. Let the point on x-axis be x, 0, and your other point is 5, -4, and the distance is 5 unit. Again, we'll use the distance formula. So AB is equal to root over of, see, y2 minus y1, which is -4 minus 0 whole square, plus x2 minus x1, which is 5 minus x whole square. Am I clear? Now put the value of AB, that's 5 unit. So 5 equals to root of, this becomes -4 square, that's 16, plus, keep it like this only. Okay, 5 minus x whole square. Now squaring both sides. So you'll get 25 equals to 16 plus 5 minus x whole square, which means 25 minus 16, that's 9 equals to 5 minus x whole square, which means, can I write 5 minus x equals to plus -3, because it will be plus minus root 9, which will be 3. Okay, so we'll have two cases, 5 minus x equals to 3 and 5 minus x equals to -3. So from here x will be what? 5 minus 3, that's 2, and from here x will be 8. So the point on the x-axis can be 2, 0 or 8, 0, which is at a distance of 5 unit from the other point, 5, -4. Done. Now let us see the next sum. Now look at sum number 5. Very interesting. Find the point on x-axis which is equidistant from the point 2, -5 and -2, 9, which means let the point on x-axis be, suppose, x, 0. Now this point is equidistant from B, suppose 2, -5, and again the distance between A and C, another point, -2, 9, are same, which means AB and AC is same. Find AB. Look over here. AB is what? Root of y2 minus y1 whole square, that's minus 5 minus 0 whole square, plus x2 minus x1 whole square, that's 2 minus x whole square. So your AB will be root of minus 5 square, that's 25, plus, and this is a square plus b square minus 2ab, isn't it? Done. So your AB square, if I find, will be 25 plus 4 plus x square minus 4x. So your AB square is x square minus 4x plus 29. Keep it till here. Similarly, find AC. So your AC over here will find AC will be root of what? 9 minus 0 whole square plus minus 2 minus x whole square, which is can be written as 9 square is 81, and minus a minus b whole square is actually a plus b whole square. So this we can treat as a plus b whole square, which will be a square plus b square plus twice ab. So your AC square will be 81 plus 4, that's 85 plus x square plus 4x. Now according to the problem, AB and AC are equal, which means AB square and AC square also will be equal. So can I write, just look over here, x square minus 4x plus 29, that's AB, will be equal to 85 plus x square plus 4x, which is AC square. AB square and AC square are equal. Okay, so this goes away. This becomes 29 minus 85 equals to 8x. Okay, that becomes minus 56 equals to 8x, or x equals to minus 7, which means the point A which we are talking about will be minus 7 comma 0. Done. Now let us see the next sum. Find the relation between x and y such that the point x comma y is equidistant from the point 7 comma 1 and 3 comma 5. Same. Look over here. Suppose this is your point A, this is B, this is C. First find AB. Look over here. AB is what? Root over of y2 minus y1, so 1 minus y whole square plus 7 minus x whole square, which is equal to, just solve it, a square plus b square minus twice ab, a square plus b square minus twice ab, that's 14x. Okay, similarly if you find AC, AC will be what? Just look over here, 5 minus y whole square plus 3 minus x whole square, which is how much? We'll just solve it. Again, this is a square plus b square minus twice ab, a square plus b square minus twice ab. Now AB and AC are equal, which means AB square and AC square will be also equal, which means can I write, see, I can write 1 plus y square minus 2y plus 49 plus x square minus 14x equals to 25 plus y square minus 10y plus 9 plus x square minus 6x. Can we write this? We have to solve this and get a relation. See, y square, x square cancels out. Okay, now this is minus 14x, this is plus 6x, so that's minus 8x, minus 2y plus 10y, that's plus 8y, and this is 49 plus 1, 50, 50 minus 34, 50 minus 34 is 16, so it will be plus 16 equals to 0. Take 8 common, so minus x plus y plus 2 equals to 0, and this is the relationship between x and y. Am I clear? Now let us look at the next sum. Now look at sum number 12. Using distance formula, show that 3 comma 3 is the center of the circle passing through the point 6 comma 2, 0 comma 4 and 4 comma 6, which clearly means, suppose this is your circle, then if center is 3 comma 3 and it passes through 6 comma 2, 0 comma 4, suppose we take 3 points, and 4 comma 6. If you can show that the distance of these 3 points from 3 comma 3 is same, then 3 comma 3 is the center, there is no doubt. Suppose this we take as O, A, B, C. Just look, find OA. OA will be root of y2 minus y1 whole square, which is 2 minus 3 whole square, plus x2 minus x1 whole square, that's 6 minus 3 whole square, which is how much? This is minus 1 whole square will be 1, plus 6 minus 3 square will be 9, so that's root 10. Keep it like this. OB, find OB. So OB is same formula, y2 minus y1 whole square, so 4 minus 3 whole square plus 0 minus 3 whole square, just look over here. So that's 1 plus 9 again, that's root 10. Similarly, find OC. Again, same. y2 minus y1, just 6 minus 3 whole square plus 4 minus 3 whole square, that's 9 plus 1, that's root 10. You see, OA is equal to OB is equal to OC, which is the radius, which means O is the center, which means 3 comma 3 is the center of the circle. Done. Now, let us see sum number 14. Using distance formula, show that the point A, B, C are collinear. Now, how do you show that these 3 points are collinear? Find AB, BC and AC, and you see when you add 2 of the length, you get the third one. Just look over here. First, find the line segment, length of the line segment AB. Look carefully. y2 minus y1 whole square, that's 4 minus 1 whole square plus 6 minus 3 whole square, that's 3 square, that's 9 plus 9, that's root 18, and root 18 can be written as, this is 2 into 9, which is 3 root 2 unit. Done. Then find BC. Same logic, root over of y2 minus y1 whole square, that's 6 minus 4 whole square plus x2 minus x1 whole square, that's how much? So that's 2 square, that's 4 plus 4, that's root 8, that's root of 4 multiplied by 2, that's twice root 2. Done. Then find AC. Look carefully. AC is what? Same, the logic remains same. 6 minus 1 whole square, 6 minus 1 whole square plus 8 minus 3 whole square, which is how much? This is 5 square, 25 plus this is 5 square, 25, that's root 50, that's twice into 25, that's 5 root 2. Now clearly if you see AB plus BC is coming as AC now. Just look carefully. 3 root 2 plus 2 root 2 is 5 root 2, isn't it? So AB plus BC equals to AC. It clearly means that A, B, C are collinear, lying on the same straight line. Am I clear? Now let us look at the next sum. Now look at sum number 17. Very easy. Show that the point A, 1, 1, B, minus 1, and C, minus root 3 form an equilateral triangle. Very easy. Find AB, BC and AC and see that they are equal. First of all, I'll find AB. Look over here. Root of y2 minus y1, that's minus 1 whole square plus x2 minus x1 whole square, that's root of, that's minus 2 square, that's 4 plus 4, that's root 8 unit, isn't it? Similarly, find BC. Look over here. BC is root root 3 minus of minus 1, that's root 3 plus 1 whole square, plus minus root 3 minus of minus plus 1 whole square, which is, now this is a plus b whole square, which is a square plus b square plus twice ab, and this is a minus b whole square, which is a square plus b square minus twice ab, isn't it? This and this cancels out. This is root 8 unit. Same. Let us find a c now. Same logic. Root 3 minus root 1 whole square plus minus root 3 minus 1 whole square. Now, this is root over of, this is a minus b whole square, a square plus b square minus twice ab. And this, I've told you, minus a minus b whole square is nothing but a plus b whole square. Minus a minus b whole square is nothing but a plus b whole square. So we can use a square plus b square plus twice ab. This goes away. So minus, so it's root 8 unit only. Am I clear? So you see AB, BC, AC, they are all equal, which means it's the vertices of an equilateral triangle. Done. Let us see number 18. Show that the point 7, 10, suppose A is 7, 10, B is minus 2, 5, and C is 3, minus 4 are the vertices of an isosceles right triangle. For isosceles, you will see that two sides are equal, and for right triangle, the Pythagorean theorem will hold. Very easy. Just find AB first. y2 minus y1, that's 5 minus 10 whole square plus x2 minus x1, that's minus 2 minus 7 whole square. That's how much? That's minus 5 square, that's 25 plus this is 81, isn't it? So that's root of 106. Am I clear? Find BC. BC is y2 minus y1, that's minus 4 minus 5 whole square plus x2 minus of minus 2 whole square. That's again 81 plus 25, that's root of 106. Now find AC. Look over here carefully. AC. AC is what? Minus 4 minus 10. Minus 4 minus 10 whole square plus this is 3 minus 7 whole square, isn't it? 3 minus 7. So that's minus 14 square. That's 196 plus this is 16. Minus 4 square, 16. So that's root of, if you look carefully, that's 212, if I'm not wrong. Yeah, 212. Now see, two sides are equal, which means it's an isosceles triangle. And now look carefully. AB square is 106, BC square is 106, and AC square is 212. So clearly AB square plus BC square is AC square, which means Pythagorean theorem holds over here, which means it's a isosceles right triangle where AC is your hypotenuse, right angled at B. Okay, now let us look at the next sum. Now look at sum number 19. The point A, B and C are the vertices of a right angled triangle at A. Find the value of A, small a. Okay, now look over here. We'll draw the triangle. Coordinate of A is 0, 3. Suppose this is B, minus 2, A, and the third vertices is minus 1, 4. They are the vertices of a right angle triangle at A. They have told this. Find this small a. Okay, very easy. Look over here. First, find AB. AB is root of, just look, A minus 3 whole square plus minus 2 minus 0 whole square. Then find AC. AC will be what? Root of look over here, y2 minus y1, which means 4 minus 3 whole square plus x2 minus x1, that's minus 1 minus 0 whole square. Okay, find BC, this one. Okay, BC will be what? Same, y2 minus y1, that's a whole square, plus x2 minus x1, that's minus 1, minus of minus 2 is plus 2 whole square. Am I clear? Now find the square of all these, because Pythagorean theorem. So AB square, look carefully, will be a minus 3 whole square plus minus 2 whole square is 4 actually. Similarly, AC square will be 4 minus 3 whole square, that's 1, plus minus 1 square again, that's 1, that's 2. Okay, BC square if you find, look carefully, 4 minus a whole square, that's 4 minus a whole square, plus minus 1 plus 2, which means 1 whole square, 1 square will be 1. So we got AB square plus, we know that AB square plus AC square will be equal to BC square. So can I write, look over here, AB square, which means a minus 3 whole square plus 1, plus I'm writing AB square plus AC square, which is 2. AC square is equal to BC square, is equal to BC square. BC square is how much? 4 minus a whole square plus 1. Now we'll simplify this. Look carefully. This is a square plus b square minus 2ab plus 6 equals to a square plus b square minus 2ab plus 1, isn't it? So a square goes away. So that's minus 6a plus 80. That's twice of a is equal to 16 plus 1, 17. 17 minus 15, that's 2. Which means a will be equal to 1. Done. We use Pythagorean theorem for this. Okay. Now look. Show that the point 0, minus 1, minus 2, 3, 6, 7, and 8, 3 taken in order are the vertices of a rectangle. Also find its area. This also you can try. See, I'm just A, B, C, D. You'll find AB, find BC, CD, AD, and then find the diagonal also. Okay, you'll see that AB and CD will be equal. Okay, opposite sides are equal. This is your A, B, C, D. You'll see that AB will be equal to CD and BC will be equal to AD, and you'll find the diagonal AC and BD. You'll see that they are also equal, which means it's the vertices of a rectangle. And then find the area, length into breadth, you'll find the area. Okay, let us see the next sum. Now look at this sum, very interesting. 24. Find the coordinate of the circumcenter of a triangle whose vertices are 8, 6, 8, minus 2 and 2, minus 2. Also find its circumradius. Now just let us draw a circle and you have triangle inside it. Okay, suppose O is the circumcenter. Suppose the coordinate is x, y. Your A is 8, 6. Your B is 8, minus 2. And your C is 2, minus 2. Now we know OB and OC and OA are same length. That's the radius. So what I'll do, I'll first equate OB is equal to OC. Just look over here. OB equals to OC. So OB is what? Root of, just look, y2 minus y1, that's y plus 2 whole square, plus x2 minus x1, that's x minus 8 whole square. And this is equal to OC. Again, OC is what? Y minus of minus 2, that's plus 2, y plus 2 whole square, plus the x minus 2 whole square. Am I clear or not? x2 minus x1 whole square. Now squaring both sides. So look carefully, this becomes y plus 2 whole square plus This when you open it, a square plus b square minus twice ab. This is y plus 2 whole square plus this is a square plus b square minus 2ab. That's minus 4x. Am I clear? This portion, this, this. This is 64 minus 4. That's 60 equals to 12x, which means x is 5. Now, similarly, we can say AO equals to OB. Look carefully. AO equals to OB. Am I clear or not? Now, what is AO? AO is y minus 6 root of y minus 6 whole square. And x minus 8, x is 5. So, 5 minus 8 whole square is equal to OB. Now OB similarly y minus 2, which means y plus 2 whole square plus this is 5 minus 8 whole square. Am I clear or not? Now squaring both sides, you get y minus 6 whole square plus this is minus 3 whole square is equal to y plus 2 whole square plus minus 3 whole square. This goes away. Next part, a square plus b square minus twice ab is equal to a square plus b square plus twice ab, isn't it? Y square goes away. So that's how much? 32 equals to 16y. Y equals to 2, which means the coordinate of O is 2, 5. Now once you get O as 2, 5, find its circumradius. Very easy. Find OB. Suppose this is, we know. Sorry, this will be 5, 2. X and then Y. 5, 2. So this is 5, 2. Done. Find OB. Look over here. OB is what? Root of, that's the circumradius, okay? 2 minus of minus 2, that's 4 square plus 5 minus 8 whole square, that's minus 3 whole square. So that's become 16 plus 9, 25. So that's root 25. That's 5 unit. Done. Okay, now look at the last sum. If two opposite vertices of a square are 3, 2 and minus 1, minus 2, find the coordinate of the other two vertices. B and A. I've taken A as 3, 2, C as minus 1, minus 2. B I've taken as x, y. Leave D, we'll find it, okay? First of all, we know, see, the diagonal AC, isn't it root 2 times the side AB? We know this fact, Pythagorean Theorem, which means AC is what? Root of y2 minus y1, that's whole square plus x2 minus x1 whole square, isn't it? Equals to root 2. Okay, AB. What is AB? Look over here. AB. That's y minus 2 whole square plus x minus 3 whole square, isn't it? Squaring both sides. Okay, now the square root goes away. And this becomes minus 2 minus 4 whole square. That's 16 plus this is also 16 equals to 2 times. This will be y minus 2 whole square plus x minus 3 whole square, and the bracket comes over here. So that's 32 equals to twice y minus 2 whole square plus x minus 3 whole square, isn't it? Which means 32 divided by 2 is 16. 16 equals to y minus 2 whole square plus x minus 3 whole square. Done. This is the first relation we have got. Now we also know that AB is equal to BC. So AB, we just got AB, that's root of, this is y minus 2 whole square plus x minus 3 whole square, and BC, again, this will be root of y2 minus y1, that's minus 2 minus 5 whole square plus x2 minus x1 whole square. See, squaring both sides, what do we get? This is y minus 2 whole square plus x minus 3 whole square is equal to minus a minus b whole square. We can write a plus b whole square, isn't it? Similarly, minus 1 minus x whole square, we can write 1 plus x whole square. Remember, minus a minus b whole square is equal to a plus b whole square, because we can take minus sign common and minus square will be plus. Now we'll open this bracket. This is a square plus b square minus 2ab, a square plus b square minus 2ab. This is a square plus b square plus 2ab, a square plus b square plus 2ab, isn't it? Now x square, y square, x square, y square cancels out. Now 4y comes over here, minus 4y is minus 8y, minus 6x, minus 2x, that's minus 8x, 4 plus 9, 13. Oh, 4 goes away, 9 minus 1, 8, so that's plus 8 equals to 0. 8 taken common, so I can say minus y minus x plus 1 equals to 0, which means I can tell, if you look carefully, y equals to 1 minus x, isn't it? Now this is your second relation. What do? Take the value of y from here and put it over here. So we'll get 16 equals to, instead of y I can put 1 minus x minus 2 whole square plus x minus 3 whole square. Now just see, this is minus 1 minus x whole square plus x minus 3 whole square, isn't it? This is how much? Just wait. Yeah, 16. This is again minus 1 minus x whole square will be 1 plus x whole square, and this you open the bracket, a square plus b square minus 2ab. So 16 equals to a square plus b square plus 2ab plus x square plus 9 minus 6x, isn't it? Now x square plus x square is 2x square minus 6x plus 4x, that's minus 4x, and 9 plus 1, 10, 10 minus 16, that's minus 6 equals to 0. Take 2 common, so x square minus 2x minus 3 equals to 0. X square middle term, am I clear? So that's x minus 3 plus 1, x minus 3 equals to 0, which means x plus 1, x minus 3 equals to 0, which gives us two value, x is minus 1 or x is 3, isn't it? Now look carefully, when x is 3, y will be what? 1 minus 3, 1 minus 3, so y is minus 2, so the point will be 3 comma minus 2, one of the point. Then when x is minus 1, look over here, so y equals to 1 minus of minus 1, that is y equals to 1 plus 1, that's 2. So when x is minus 1, y is 2. So the other 2 points are minus 1, 2 and 3 comma minus 2. So this was the last sum. Keep it till here in this video. In the next video, we'll start a new chapter. Okay, till then, take care.